today's video, I will be doing the hashtag related rates challenge which was first made by Arian Mendez in her channel. So if you're interested, just keep on watching.
A street light is at the top of a 15-foot pole. A person who is 4 feet and 6 inches tall walks towards the pole with a speed of 5 feet per second along a straight path. First, find the rate at which the length of the shadow is changing. Second, find the rate at which the tip of the shadow is moving. Before we proceed, take note of all of the measurements. Notice that all of the measurements are in feet except for the height of the person. So what we will do is that we have to convert the height of the person, which is 4 feet and 6 inches, into blank feet. Since the 4 feet is already in feet, we only have to convert the 6 inches, which is equivalent to 0.5 feet. So 4 feet plus 0.5 feet will be 4.5 feet, which is equivalent to the height of the person. Here is an illustration of the problem. Not all of the light from the bulb reaches the ground because there is a person blocking it from reaching the ground, which explains why there is a shadow formed. Based from the illustration, we can say that the distance between the person and the pole can be denoted by x. Y can be the length of the shadow, and L will be the sum of x and y. The remaining given in the problem is the dx over dt, and it is negative since the person is walking towards the pole, so the distance x is decreasing. Going back to the problem, part A asks for the rate at which the length of the shadow is changing. So since the length of the shadow is denoted by y, it is the dy over dt, or the rate of change of y with respect to time. To solve for part A, we can redraw the illustration. Now we see a smaller right triangle inside a larger right triangle, so it is similar triangles. Now we can get the ratio of the bases and the ratio of the legs. Get the ratio of the base of the smaller triangle over the base of the larger triangle equals the leg of the smaller triangle over the leg of the larger triangle. Then cross multiply. 15y is equivalent to 4.5 times the quantity of x plus y. Copy 15y equals, then distribute 4.5 to the quantity of x plus y. So 4.5x plus 4.5y. And then combine all the numbers that has the same variable in one side. So 15y minus 4.5y is equal to 4.5x. And then get the difference. So 10.5y is equal to 4.5x. Once you get to this part, you have to perform implicit differentiation. So 10.5 times dy over dt is equal to 4.5 dx over dt. So since dx over dt is already given, you just have to copy 10.5 dy over dt, which is our unknown, is equal to 4.5, and then substitute the value, which is equivalent to negative 5 feet per second. And then multiply. So 10.5 dy over dt is equal to negative 22.5 feet per second. So since we are finding dy over dt, we have to divide both sides of the equation by 10.5. So divided by 10.5, and the other one 10.5. and then we cross out. So dy over dt is equal to negative 2.14. So that is our answer for part A. Part B asks for the rate at which the tip of the shadow is moving, or at what rate is the shadow moving with respect to the base of the light source. So we have to find the dl over dt. So instead of using y over x plus y, we have to change the x plus y into L since L is equal to x plus y. So in this part, we have to find the dl over dt. Still using the previous equation, y over L is equal to 4.5 over 15. Cross multiply. 15y is equal to 4.5L. Once you get to this part, perform implicit differentiation. 15 dy over dt is equal to 4.5 dl over dt. Since we already solved the value of dy over dt in part A, copy 15 and then substitute the value, which is negative 2.14 feet per second, is equal to 4.5 dl over dt. Then multiply. Negative 32.1 feet per second is equal to 4.5 dl over dt. Since we have to find the value of dl over dt, we have to divide 4.5 to both sides. So over 4.5 then over 4.5. So the value will be negative 7.13 feet per second. D is equal to dl over dt. So that is our answer for part B.